Welcome to the Deep Dive, your shortcut to being genuinely well-informed. We distill insights from key sources for you. Today, we're plunging into deep learning. It's a technology that's, well, fundamentally reshaping our world. Our source material is an excerpt from Deep Learning, AI's brain-inspired revolution. And our mission, to really unpack it. What is deep learning? How does it actually work? And why is everyone calling it a revolution? You know, it wasn't long ago that things like accurate machine translation or real-time face recognition seemed almost like sci-fi. So what changed? What was the missing piece that deep learning brought to the table?
Yeah, it's a great question. What's really fascinating is that deep learning is a branch of AI that specifically tries to mimic how our own brains process information and, make decisions. It's built on something called artificial neural networks. Think of them as mathematical structures, really, designed to sort of emulate brain cells. And they're not flat. They have multiple layers interconnected. Each layer learns a progressively deeper or more abstract feature of the data.
Okay, that brain-inspired idea is really compelling. But sometimes metaphors can be a bit loose. How closely does it actually mirror our gray matter, or is that maybe a common misconception? And what's the real difference between this and, say, traditional machine learning?
That's a really sharp point. It is inspired by the brain, but definitely not a direct copy. The biggest difference, and this is where the revolution part comes in, is how it deals with features. So features are just distinct bits of information in the raw data, right? Like pixels forming an edge in a picture, or specific sound frequency in speech. In traditional machine learning, humans data scientists had to figure out and manually select these features for the algorithm. It was painstaking work, deep learning. Well, it mostly bypasses that. It automatically learns these complex patterns and features directly from the raw data itself. Images, text, sound, it finds things we might not even think to look for. That ability to learn without being explicitly told what patterns matter. That's the huge shift.
Okay. So it's less about following a pre-written rule book and more about discovering the rules itself from the data. That sounds like the engine behind a lot of the really advanced tech we interact with, maybe without even realizing it. Where is this engine actually running in our daily lives? Are there examples so common we just take them for granted?
Oh, absolutely. It's become incredibly pervasive. Deep learning is really at the heart of so much modern tech. Think about facial recognition unlocking your phone. That's very often deep learning. Or the way online translation tools have gotten so much better, more fluid. Self-driving car technology relies heavily on it for perception and decision making. And of course, those intelligent assistants, Siri, Alexa, Google Assistant, understand your spoken commands. Deep learning is key there.
Wow, it's kind of mind-boggling, the complexity these systems handle. Which
Yeah.
makes me wonder, where does all this power come from? What actually enables deep learning to do these things? And what does it need to, function properly?
Its real strength is its ability to process and learn patterns from absolutely massive amounts of data, just enormous data sets. The more data it sees, generally, the better it gets, the more nuanced its understanding becomes. But, and this is important, this power has some pretty hefty requirements. It demands a lot of computational power. We're talking specialized hardware, often GPUs, graphical processing units that are good at parallel calculations. And like I said, vast quantities of high-quality data to train on in the first place. You need both the data and the power.
Right, so it's like a high-performance engine that needs premium fuel and a lot of it. Are there different kinds of these deep learning brains or models, like specialized types for different tasks?
Yes, definitely. The field has developed various architectures, each tailored for specific kinds of beta or problems. For anything visual, like image recognition, you have convolutional neural networks, or CNNs. Think of CNNs as using lots of little filters that scan across an image, each looking for a tiny specific pattern, maybe a line, a curve, a texture. Then you layer these so the network builds up from simple patterns to more complex ones. Lines become edges, edges become shapes, shapes become objects like eyes or wheels, and eventually a whole face or a car. Actually, there was a funny early example where a model identifying dog breeds got confused. It wasn't looking at the dogs, but the snowy backgrounds common in photos of one specific breed. Shows how they learn patterns, but maybe not always the ones we intend. Then for data that unfolds over time, like sequences, think text, or speech, there are recurrent neural networks, RNNs. These have connections that loop back, giving them a kind of short-term memory. They can consider previous words when processing the current one. And more recently, we have transformer models. These are the real heavyweights behind things like ChatGPT and other large language models. They're incredibly good at understanding context and generating human-like text.
Okay, so it's definitely more than just simple mimicry. It's about enabling machines to perceive and process information in genuinely new ways. If you had to boil it down for us, as people who use this tech or just observe it, what's the main takeaway from this deep dive?
I think the key thing is that deep learning represents a shift towards machines that can learn complex patterns more autonomously. It automates this incredibly difficult task of extracting meaning and structure from vast, messy data. And that capability is fundamentally changing how information is processed, how we interact with technology, and it's powering a huge amount of the AI you encounter every single day, often behind the scenes.
Yeah, this really highlights how that brain-inspired layer-by-layer learning allows machines to do things like recognize your face instantly or understand complex voice commands. It's easy to forget the sheer sophistication running underneath the surface of the tech we use.
And maybe a final thought to leave you with. If deep learning gets its power by mimicking, in a sense, the brain's ability to learn from huge amounts of data, what might that imply about our own intelligence? Especially as these models get even more complex and, frankly, data hungry. It's something to consider.
A really fascinating point to chew on. Thank you for joining us on this deep dive. We hope you continue exploring these powerful and truly captivating topics on your own.